Okay, so for this exercise, you're gonna have to factor this one to start, and then go from there. Probably use this formula up here at some point. Anyways, the answer is here. You can copy that down, and then ponder this next example, which I will do for you. Now, this is different this time. We have something different happening on the bottom. Okay, so this, it's called a linear factor, but it's repeated. We call that repeated linear factor. Okay, it's repeated because, well, it's linear because it's ax plus b. Oopsie daisy. And it's repeated because of this 2 here, power of 2. Now, this x squared, that is also a repeated linear factor. Okay, so for this case, we do something different. Okay, so because the x appears squared over here, the pattern to follow is this right here. Now, that's not obvious, but it's a fact of algebra. Now, x plus 2 is squared as well. We will follow the same pattern. So we're going to need 2 letters. There. Now, I'll just say it. If this were a 3, then I would have another term over here. It would be e over, x plus 2 cubed, if this were a 3. Okay, so I hope the pattern is clear enough. So this is the partial fractions decomposition we will follow. So we do our usual thing. Now what I'm going to do is ask you to imagine this denominator appearing here, here, and here. Oh, and also here. So in those 4 places, I want you to imagine it appearing in those 4 places when I, multiply to clear fractions. So what's going to happen is that this x here is going to cancel, one of these x's. So I'll get just x plus 2 squared plus b. Now this x squared is going to cancel all of that. So I'll just be left with x plus 2 squared plus c x squared x plus 2 plus dx squared. So to get this line here, I multiplied to clear fractions. Okay, now same as before. Oopsie daisy. Now same as before, I make clever choices for x. X equals 0. It's going to help me. I'm going to get 4. 0 plus what, 4b. Oh, that's it. So b is 1. So x is 0. It works out nicely. X equals minus 2. We'll do something good for me, I believe. Negative 4 is equal to just 4d. So d is equal to negative 1. Now what? Well, I have b, I have d. I've used up all my clever ideas here. So I'm just going to choose some small numbers to see what else I can do. So I'll just go x is 1. Let's say. Okay, not a particularly clever choice, but will allow me to move forward here. So 1, I get 1 times 9a plus 9b plus 3c plus d. Okay, and I have b and d from above. So I could say 5 is equal to a plus 9 plus 3c minus 1. So negative 3 is 9a plus, oops. Let me see, yeah, and why don't I divide by 3 to get 3a plus c is equal to negative 1. Okay, then I'll do negative 1. Negative 1. Okay, so what am I doing here? So I'm going to have to scroll back and forth here, I'm afraid. 3. Negative 1. So I get 1 times negative 1, so negative a. Negative a, oh boy. So I got negative a, negative 3, plus b plus c plus d. Okay, I think I can remember that. Plus b, whoa, that's a funny b. Plus c plus d. And then what was it? B is 1, d is negative 1. Okay, so 3 is equal to negative a plus C. Okay, so what I have here is these two rectangles. That's two equations, two variables. You can solve by, say, substitution. C is equal to minus 1 minus 3a. So I solve for C here, and then I can plug it in there. And what do I get? I get 4 is equal to minus 4a, and that seems nice. A is minus 1. And C is equal to minus 1 minus 1 minus 3a. So C is equal to 2. Okay. Let's see. I think I'll leave the rest of this to you to try. Okay, I found A, B, C, and D for you. And I want you to try to finish this example.